To start this problem, I would just look at the key info that's given to you. So we're dealing with a quadratic in standard form. We got some key points that are given. So whenever you're given points, you should think, oh, I can plug that in to whatever function they're giving us. So we can put that in here. And then we want to find a, which is an integer greater than 1, and then we want to find a plus b. So that's some key info given in this problem. And then from there, we can just kind of work it out. So like I said, we're going to first want to plug in 7o. So let's do that. So we got f of 7 is going to be 49a from plugging in a 7 squared plus 7b plus c. And then f of 7 is 0 because it's given to us as the y value. So 0 equals 49a plus 7b plus c. And then same thing. Let's plug in f of negative 3. So then when we do that, we'll get 9a minus 3b plus c. And then the 9 comes from negative 3 squared. When you square a negative, it becomes positive because a negative times a negative is a positive. So then let's plug in a 0 for f of negative 3. So when we do that, we'll get 0 equals 9a minus 3b. Okay, and then plus c. So then one thing you'll notice is that both of these equations, let me underline them in green, are equal to 0, which means they're equal to each other. If they're equal to the same thing, they're equal to each other. So then we can set 49a plus 7b plus c is equal to 9a minus 3b plus c. We can cancel out a c on both sides, leaving us with 49a plus 7b equals 9a minus 3b. And then let's move all the variables to one side and then combine them. So subtract the 9a and then add the 3b over. So then you're left with 40a equal plus 10b equals 0. You can factor out a 10, so then you're left with 10 times 4a plus b equals 0. And you can divide out a 10. I'm going to move that over here. And then you're left with 4a plus b equals 0. What I did is 0 divided by 10. So you divide by 10, 0 divided by 10. Any number with 0 in the numerator is going to be 0. So then now we're very close. 4a plus b is very similar to a plus b. The only difference is, the a's got a 4 as the coefficient now instead of 1. So then what you can do, and then we know that a is an integer greater than 1. So what I recommend doing here is just, you can start plugging in some numbers and see what happens. So I would solve for b, and then we get that b equals negative 4a. So that tells us that b has to be negative 4 times a. So if a is like, let's say 1, then that means b has to be negative 4. So now what I would start doing is I would start plugging in some numbers for a that are greater than 1, and then see what b has to be in that scenario, and then see if the answer choices line up. And I'll show you what I mean by that. So the first option is a equals 2, right? Because that's the first integer that is greater than 1. So for a equals 2, we got 4 times 2 plus b equals 0. We know that b has to be negative 8 because of this rule. So b is going to be negative 8, and then a plus b then is going to be 2 minus 8, negative 6. Is that one of our choices? Oh, it is. It's A. And there you go. We're done. So for this question, there is an alternate way you can do it with the axis of symmetry in the quadratic. I've solved this question that way before. But if I was taking the SAT myself, I would solve it just by doing some algebra and then plugging the numbers in and seeing what works, because you don't have a lot of time on the SAT. And I think that this solution that I showed right here is a surefire way to get this question right and similar questions. So I hope you guys liked the video. Make sure to like, subscribe, and I will see you guys in the next one.